Hey, have you ever looked at a garden path or maybe a picture frame and just wondered, how much space does that border actually take up? It seems simple enough, but this is one of those classic problems that can totally trip you up, whether it's on an exam or your next big DIY project. So today, we're going to completely master the math of pathways. You'll be able to solve these problems with total confidence.
Seriously, just think about it for a sec. That gravel border around your flower bed, the matting inside a picture frame, even the lanes on a running track. Yep, they're all just pathways in disguise. And whether you're trying to buy the right amount of materials or aiming for a perfect score on a test, knowing their exact area is absolutely key. So let's break down how to nail it.
So here's our game plan. First, we're going to start with the single most important formula, the one rule that governs all of this. Then we'll tackle three common scenarios: paths on the inside, paths on the outside, and, you guessed it, those tricky crossing paths. And to wrap it all up, I'll give you a super simple checklist so you can get it right every single time.
All right, let's get right to the heart of it. You might actually be surprised to learn that no matter how complex one of these pathway problems seems, it all boils down to one simple, really powerful idea.
And here it is. This is the master key to everything. The area of any pathway is just the area of the big outer shape minus the area of the smaller inner shape. That's it. Seriously, no matter what kind of path you're dealing with, this is the fundamental rule. If you can keep this one idea in your head, you're already halfway to solving any of these problems.
Okay, so let's put our new master formula to the test, right? Challenge number 1, the inside path. I want you to imagine you've got this beautiful garden and you decide you want to build a little stone path right around the inside edge. Well, that path is going to eat up some of your garden space, isn't it? Let's figure out exactly how much.
So, in this scenario, the whole garden is our outer shape. The path is built on the inside, which leaves a smaller patch of green in the middle. Our job is to find the area of just that stone path.
Let's just walk through this together. First up, we find the area of the entire garden, which is easy enough. 10 by 8 is 80 square meters. Now, here's the crucial move. To find the size of that smaller, inner garden, the green part, we have to subtract the path's width from both sides of the length and from both sides of the width. That's why we subtract 2 times the path's width. So our new inner garden has an area of 48 square meters. And now we just use our master formula, outer area minus inner area, which gives us a path area of 32 square meters. Boom.
So here's the big takeaway for inside paths, the thing to remember. You start with the big outer dimensions and you subtract twice the path's width to get your new smaller inner dimensions. It's as simple as that.
Okay, challenge 1 is down. We've handled inside paths. But what if you're adding a border around something? Like putting a mat around a photograph before you frame it. This brings us to our second challenge, the outside path.
See, this time, the photograph itself is our inner shape, and we're adding the margin, our path, to the outside. This means the whole thing is going to get bigger. We're still going to use our trusty outer minus inner formula, but how we get there is just a little different. Let's follow the logic here. We start with what we already know, the area of the photo, which is 600 square centimeters. Now, to find the new, bigger outer dimensions, we have to add the margin's width to both sides of the photo. That's why we're adding 2 times the margin width. This gives us a new total outer area of 875 square centimeters. Then it's back to our master formula, outer minus inner, and we find out that the margin itself has an area of 275 square centimeters.
And that right there gives us our second golden rule. When the path is on the outside, you start with the inner dimensions and you add twice the path's width to find the outer ones. So let's just recap real quick. Inside paths, you subtract. Outside paths, you add. See the pattern?
All right, we have totally conquered inside and outside paths. So now it is time for our final challenge, what some people like to call the final boss of pathway problems. What happens when 2 paths cross right over each other?
So picture this. You've got a big rectangular park. There's a path running straight down the middle, north to south, and another one running east to west. They meet right in the center. The big question is, what's the total area of pavement?
Okay, here is the secret to solving this one. If you just calculate the area of the long path and the area of the wide path and add them together, you've actually made a really common mistake. You've counted that little square in the middle where they overlap twice. We only want to count it once, right? So the key is to add the areas of the 2 big paths and then subtract the area of that little overlap.
Let's look at the numbers. First, we get the area of the path that runs the length of the park. That's 100 square meters. Then, we get the area of the path that runs across the width. That's 60 square meters. Now, for the most important part, the overlap. It's a 2 meter by 2 meter square, so its area is 4 square meters. So our final calculation is path 1 plus path 2 minus the overlap. That's 100 plus 60 minus 4, which gives us a total path area of 156 square meters.
And that is our third and final golden rule. For crossing paths, you always have to remember to subtract that overlap. It's the one extra little step that makes all the difference between getting it right and getting it wrong.
So there you have it. We've broken down the 3 main types of pathway problems. Now, let's just pull it all together into a simple little checklist that you can use to tackle any of these questions with complete confidence.
First things first, just take a breath and figure out what kind of problem you're looking at. Is the path inside, outside, or crossing? Next, and trust me, this is a big one, always draw a quick sketch. It doesn't have to be a work of art, but it will seriously help you see what's going on. And of course, the basics still matter. Make sure your units are consistent, double-check your math, and make sure you know your basic area formulas. Follow these steps, and you'll be golden.
So that's the logic of pathways, all broken down into just a few simple rules. That core idea of outer area minus inner area is way more powerful than you might think. Now that you've got it down, what other shapes out there in the world can you start to see in a whole new way? Thanks for sticking with me on this one.